or use of nanomaterials in self-conducting motors for the applications of repair of historical structures. That is the topic we discussed. Okay, that is why I choose that last topic, morning topic is. I think it is the title of this program is almost close to that nanomaterials. That's why I choose that. Next generation concrete technology utilizing nanomaterials for the development of standard and smart structure. Remove that nanomaterials. Next generation concrete technology for the development of strong and smart structure. Okay, that is, if you remove that nanomaterials or nano inclusions, then it is also useful. What is the meaning of next generation? Okay, next generation means next type of the concrete. Next type of the concrete. There are so many types of concretes. You know that. Okay, one of this self-compacting concrete, geothermal concrete, fiber-based concrete, concrete is the nano materials, and any other fibers with natural fibers and artificial fibers. There are so many concretes with the different applications. Underwater concrete. Okay, some repair applications you can go for the underwater concrete also. Okay. Here, next generation means you want to reduce the cement content. Okay. Now, for example, if you can go for that geothermal concrete, okay, definitely 100% we are not using cement, but there are a lot of problems. Lot of problems means we are purchasing that alkyl actuators, sodium hydroxide, sodium silicate, and the reaction will be very fast sometimes. Okay, you can use that gloves and everything while casting. Otherwise, your skin may be damaged. You cannot put the hand into the concrete. Okay, some difficulties also there in the geothermal concrete. One more major difficulty in the geothermal concrete is fast setting. If you cast that concrete during midday, that means 12 to 2, okay, 12 noon to 2 p.m., without taking the material from that drum or mixer, it will settle, it will harden. Okay? My students face a lot of problems. Without casting, the entire concrete is hardened. Thrown away. Okay, that's why you can use that cement, little bit amount, and replace the cement with other materials. What are the industrial byproducts are available in that? You can use. That is nothing but multi-component binders. Multi-component binder system. That means, can anybody explain that what are the industrial byproducts available in the name of secondary cementation materials? Fly ash, GGBS, metakaolin, and silica fume, rice cash. Okay, these are the things. Okay. If you combine all these things in replacing the cement, we call it as multi-component binders. It may be binary. That means they replace the cement with two components. That means cement plus fly ash, binary. Cement plus fly ash plus GGBS, tertiary. Cement plus fly ash plus GGBS plus silica fume. Okay, quaternary. Likewise, that is called as multi-component binder system. What is the influence of this multi-component binder system in the development of self-compacting motors with fiber reinforcement? What is the application of this fiber reinforcement in self-compacting motors? What is the use of fibers in the concrete? Regular strength increase. What is the application? It will arrest the cracks. It will reduce the just micro cracks. Micro cracks become macro. Then, if you add the fibers into the concrete, the number of density of the cracks are increased. but the crack length, crack depth is less compared to that without the fibers. What is the application of this fiber reinforced self-compacting motors? Earlier, we are using that fiber reinforced self-compacting motor with nanomaterials. The application is repair material. But here, you can use this fiber reinforced self-compacting motors as a repair material and also as a shotcrete. Anyone have a shotcrete? For stability of the walls in the tunnels. Okay, for stability of the walls in the mines, shotcrete. If you have anyone recently go to the Tirumala, you can observe that shotcreting because I observed that. Shotcreting in the guard road. Shotcreting is there. They put that some anchoring and pressure pneumatically applied. Shotcreting nothing but pneumatically applied that material with high pressure. There are two types of shotcretes actually, dry mix and wet mix, that is the different story. And in that mix we are using this fiber reinforced self-compacting motors. Okay, one aspect is we want to reduce that cost, we want to reduce that usage of cement. Another aspect is we want to use that whatever the waste materials available in that machine. Okay, that's why we are using this multi-component binder system and fiber reinforced self-compacting motors. Okay, agreed. Everyone is agreed. We can add in n number of materials in the cement because they are cementitious properties. So you can add n number. Fly ash or DGBS, all the materials you can add. How to add? Any method is there? But if you see the literature, they are adding n number of 4 types of materials replacing cement. There is no methodology, there is no proof how that strengths are gained, nothing. Okay? They are taking randomly 65% of cement, 35% of fly ash, again 60, 70, 100, 80, 90. There are so permutation combinations. But proof, authentication is very important in research. Proof is very important. What is the definition of science here? Because you have background of science. Science. You have studied so many sciences. Physical science, social science, natural science. So many sciences. What is the science? Proof is required. For science means observe the things and satisfy with the proof only. Newton's okay, apple fell down. The proof is there is a gravity is there. That's it. That is observation is there and proof also is there. That is the best research. Without the observation, without the proof, simply adding the materials and get the results. Okay, I have this much of strength. I have this much of strength. No, nothing. That days are gone. Okay. If you observe that publications, because many are research scholars, if you observe the publications, if you have any new thing, then only they will accept. I am not talking about the paid journals. Paid journals, you can pay the 5,000 rupees today, you can get that paper next day itself. There are so many. International Journal of so and so, International Journal of Science and Technology, there are so, but that's not so. For sake of publications, you can spend 5,000, 10,000. There is no use at all. Okay. Forget about it. Okay. Then I will do the same definition of self-compacting motors. Can anybody give me? Okay, I will give the same definition. Anybody give the new definition of self-compacting motors based on that morning session? Anybody can give? Based on the morning session, what you understand? What is the definition of self-compacting motor? By its own weight, it can be compacted without any extra energy in the name of compaction or in the name of damping. I think same definition may be there. Self-compacting motors as advanced building materials are principally used in rehabilitation repair of infrastructures, without any external compaction, and at the same time Okay, one more point is missing. Without segregation, without bleeding, you can get the self-compactability very easily by adding the water. If you observe the last person asked one of the doubt morning, why the new constructions are not so good? That's why there. Okay. Why the new constructions are not so good? If you observe that concrete mixer near the site, what they are using? Drum is rotating. They are pouring the aggregate, they are pouring the cement and sand, everything. The layman is there. They want to make the workable. They want to do the work easy for mixing or placing or water, for vibrating anything. They will pour the water without any quantity, without any measuring of the quantity. With this sense only, with this experience only, with this experience, they are continuously adding the water. Okay, it can easily flow, it can easily pumpable, it can easily place it. But what will happen? This water gives the, after hardening, this water gives the voids, it creates the voids. The concrete is not so more dense. There are so many voids also. Once the concrete have the voids, it will attract the aggressive agents. The voids attracts the aggressive agents. Okay, once the concrete becomes alkaline to acidic, once the concrete becomes alkaline to acidic, the corrosion comes. That is the reason I gave the answer. Quality of the concrete is very important. Okay, here you can compact it very easily without any extra energy, but it should be segregation resistance and bleeding is the thing. Without causing segregation is the main scientific and academic advantage of self-compactability. Tag is there. If you observe that, Ashad Mass is there. Okay, anyone observe that one? Big letters 70 up to 70% discount. Top UPTO up to cannot observe that one. It is very small. But we think that okay, 70% of discount is there. Sometimes 70% discount is there, one star mark is there, at the bottom conditions applied. Likewise, self-compacting mortars have compacted by its own weight. The another tag is without segregation and bleeding. That is more important. The advantage of this self-compacting mortars can be used for generally plastering purposes or repair materials because of less labor cost, and you can finish the work within that time. Okay, that's why somewhere else. And what are the applications of this self-compacting mortar is already discussed here. Crack repairs, in the last session also we discussed, and dam proofing. Dam proofing, you can observe that one, how they are using that dam proofing. They are injecting that some chemicals, damping material, anti-dam proof materials. Okay. They are anti-dam proof material is a chemical. Along with the chemical, they are using some cement slurry. We can use the cement slurry for this. And rehabilitation of the structure. These are the applications of self-compacting mortars. Already discussed in the last session. Self-compacting mortars requires more powder. Not only the self-compacting mortars, self-compacting concrete also requires more powder. More powder in the sense, not the talcum powder, not the any other powder. Cement powder in the sense binder. More binder is required. If you can go for the more binder, it is more costly. At the same time, shrinkage problems also there. High cement content needed in self-compacting mortar to increase their flowability and stability, and inert fillers and supplementary cementitious materials are usually used for this purpose. In order to avoid the uses of cement, you can go for that another SCMs, supplementary or secondary cementitious. You can call it supplementary or secondary cementitious materials. Okay, what are the materials? Already explained that. One is blast furnace slag, GGBS, metacolin, silica fume, rices cash, fly ash. But I have mentioned the 3 here means one case study is also there. For that case study I am using this 2, 3 PF, GGBS, metacurrency. Okay. Can also produce the self-compacting motors without any problem of segregation and liquid. Okay. These are the some of the materials BFS, that is blast furnace slag, metacurrency. One more important point in self-compacting motor, rheology. Rheology in the sense nothing but viscosity and shear stress. Okay, viscosity is very important. That's why, but I didn't discuss this point in the last session also. You can, along with that super procedure, you can go for the VMA also. Viscosity modifying agents. Okay, viscosity modifying agents also useful for modifying the viscosity and check this viscosity of this self-compacting motors or concrete by using the rheometer. Okay, rheometer cost is around 20 lakhs, but we didn't purchase that rheometer. That is also one of the study to check that rheological properties of the self-compacting concrete and self-compacting mortar with different materials. That is also different study. Okay. Face-to-face rheology of repair mortar should have certain properties from the probability point of view. Okay. These are the advantages already discussed here. Reduce the construction time and labor cost. How the labor cost is reduced? Anybody? Self-compacting concrete and mortar. There is no person who operates the vibrator, and it is totally pumping. It is totally pumping, cannot make that self-compacting concrete in the site itself. You can prepare the self-compacting concrete or mortar in the ready mix plant. Simply transport that concrete to the site and pumping. Okay. Manpower is reduced, and construction time. Construction time means it can quickly settle, quickly harden. Therefore, automatically the removing of the shutters, everything is reduced. And filling capacity of highly congested structure. Filling capacity means, for example, if you can imagine that, because I am talking about the SCC, if you are imagining that beam column joint, this is a column, one beam is in this direction, another beam is in this direction. How this beam column is congested? Imagine. Okay, one vertical bars are moving in this direction, horizontal bar x direction, another direction, z direction also there. This beam column joint is very congested, very congested, and that is also that as you know that structural engineers all know that point is very important. If that beam column joint is failed, entire structure. In that case, you can go for this self-compacting concrete. Obviously, it can go each and every corner of that reinforcement without any extra force. Okay? If you can see that normal concrete, even though if you are applying the vibrator, you can get that honeycombing. Anyone have observed that honeycombing? Okay, honeycombing means the surface is not so smooth. If you can use the self-compacting concrete, you cannot go for the plastering also. If you observe any building, some of the buildings in the IIT Tirupati, they are constructed that self-compacting concrete without any plastering and without any painting also. Some of the hostels, they are really self-compacting. Okay, that is one of the advantages of self-compacting concrete. Just fiber reinforced self-compacting concrete. Fiber reinforced means you can add the n number of fibers. N number of fibers means monofiber, hybrid fiber. That means monofiber means, for example, if I can use steel fiber, and along with the steel, if I can use polypropylene fiber, basalt fiber, or glass fiber, or what are the fibers? Depending on the length of the fiber, depending on the diameter of the fiber, depending on the aspect ratio of the fiber, type of the fiber, shape of the fiber, there are so many things. If you can take the steel, crimped fiber, cooked fiber, plain fibers, so many fibers, so many aspect ratios are available. Here the the mechanism of fiber reinforced concrete or fiber reinforced mortar is, for example, this is the fiber, this is matrix or concrete order. Okay, if you can observe that flexure, bending or tensile force, okay, this fiber will try to come out from the matrix. If you can maintain the good bonding between the matrix and the fiber, it will take more load for failure. And one more thing is, after that, if the elongation of this fiber is more, it will take more loads. If anything is failed, if the bonding between the matrix and the fiber is failed, there is no question of fiber reinforced concrete. If the fiber itself is failed suddenly, there is no question of fiber reinforced concrete. That's why you can add the two types of the fibers, because small fibers and long fibers, glass fibers and steel fibers. Okay, glass fibers will take the initial cracks, initial loading. Okay, then after the peak load, the steel fibers are coming to the action. That is the one of the technique we call as the hybrid reinforced fibers. We can also use the same hybrid fiber reinforced. Okay. In the fiber reinforced SCM, fibers are usually discontinuous and randomly distributed throughout the compound. Therefore, we call this fiber reinforced self-compact mortar is a composite material. Is a composite material, and fibers are randomly distributed. We are not using horizontal or vertical direction. While mixing itself, the fibers are distributed randomly. Okay. In the hardened mortar, fibers prevent the micro cracks from developing into macro cracks. This is the advantage of fiber reinforced concrete. In the fiber, if you can observe that fiber reinforced concrete and normal concrete, more cracks are there in the fiber reinforced concrete. Only one or two cracks are there in the normal concrete, because sudden failure is there in the normal concrete. If you add the fibers, you can avoid that sudden failure. Yeah. Hybrid fiber reinforced self-compact mortar is a new composite material by adding different types, shapes, dimensions of the fibers in self-compact. You can add any n number of fibers, but only thing is which fiber is the predominant. You must know that. Okay. It improves the if you can add that two fibers, then automatically the strength properties, especially the tensile strength, increase compared with that mono fiber. Okay, that's why mono fiber and hybrid fiber are different. In order to consider the hybrid fiber, you can take two aspect ratios: small fiber, long fiber. That is advantage. Don't take the long fibers as a 2. Don't take the small fibers as a 2. Right? And one more thing is lubrication effect. The self-compact mortar, lubrication is very important. Okay, how can you get the lubrication? Means the paste is more elastic and you can get that more lubrication. Water not only provides lubrication by wrapping pores aggregate, but it also predominantly with the pressure properties. With low yield stress and viscosity. Yield stress and viscosity can get that rheometers only, not from the anything. Here we see the two parameters actually, three parameters for the self-compact concrete and mortar. I didn't discuss in the morning session. Filling ability, passing ability, and saturation. These are the main characteristics of self-compact. Filling ability. What is the meaning? The concrete can fill that molds or fill that area very easily. That is called filling ability. In that filling ability, you can check that L box test in case of self-compacting concrete. You can check the beef and also the filling. Passing ability, you can check that slump flow. Any slump cone or slump flow, passing ability, and also can check that L box and J ring also there. There are so many tests as per FNR guidelines. And sacrifice resistance against it is also L box and B funnel. But we are not using that L box, B funnel and all the things in these mortars. Okay. If you want to develop self-compacting concrete, first design the self-compacting motor and then preparing of self-compacting concrete is very easy. That is the one of the points I want to discuss here. Yeah. Many others, I already told you, many others or many researchers used all the materials, what are the materials available in the market, like silica fuel, metacolumbar, blast furnace slag, fly ash, everything. But as per the literature, you can restrict for 65% of cement, 35% of the other materials. The restriction is already there, I think, somewhere. Yeah. If you can go for 1 or 2 or 3 or 4 multi-component binders, that limited to 35% of replacement. Remaining 65% is cement. It is there in the literature. Okay. You can go for the n number of materials, 1, 2, 3 or 4 supplementary suitable materials with the substitute levels reaching 35% when mass of cement. That is proven. Okay. I took that part. Okay, here the same case study. Okay, I done this case study at Slovak Republic. Therefore, all the standards are from Slovak Republic. It is also European. I think you may know that Czech. I think you studied in the history Czechoslovakia, and they are divided in making into 2 republics, Czech Republic and Slovak Republic, just like Andhra Telangana. They are very close, very near, but they are separated into 2 republics. Okay. I visited Slovak Republic and stayed for 3 months there and done the study, simple study, but it is very interesting because how you are adding that materials is very important. In that case also same, because mortars very simple, concrete is very difficult. That's why whenever I visited the foreign countries, I choose mortars. Okay. Preparation of the samples, testing of samples are very easy. It's small samples, and you can get that less material is enough. That's why whenever I visit any foreign country for research purpose, I choose only mortars. Just I want to visit Poland also. I am planning for geothermal mortars with multi-component with the combinations. Okay. Same 1:1 and 1:2 mixed proportion, and cement, GG-base, metacolumn, and how many? 4 components. That's why we call it multi-component binders. And same fibers, same self-compacting motor with fibers, not 3, 2 types of fibers. One is polypropylene, and one is basalt fiber. Basalt fiber is not easily mixed with that motor. We take the fiber and by using that mixing, what we are using the kitchen appliances, we are using the mixing and we mix the fiber thoroughly in the water, then only we mix it in the water. So that is some precautions are required while taking this type of basalt fiber. The materials we are using are cement type 1. 42.1R. This is from Slovak Republic. The surface area of the cement is 4,341 centimeters per ton. Next is GG-base. In the GG-base, 78% of glass content is there, and specific surface area of 4,275 centimeters per gram. This is from Czech Republic. Nearby, because the Slovak there are no power plants, they are totally depending on the wind resource. Wind and this atomic energy. Next is metacolumn. This is also MK. It is MK Mephisto. That is actually this language Slovak language. You can understand that. There is a specific surface area of 2,586 centimeters per gram. And silica fuel, the specific surface area is 15,000 centimeters per gram. This is from Slovakia. Out of all these 4 materials, which one is final? This is only 4,300. This is 4,200. GG base, and metacolumn 2500 and silicon is more factor. Okay. Therefore, I want to tag the things, tag the material very close. Okay, my students use that multi-component binders. They are using wet packing theory. Okay, not by simple method by 60%, 40%, not like that. They are using the wet packing theory. Based on the wet packing theory, they are calculating the density of the combination, each combination, and which material have the more density and less weight ratio. They are choosing that. There are a lot of combination combinations in the wet packing theory. Okay. Each material, for example, 5% silicon remaining GG base. You can change in all the parameters, all the combinations, and they are calculating the wet packing of each material and find out the final density of and weight ratio, and which material, which combination is more density and less weights. They can choose that. That is one method. And for choosing of the coarse aggregate fine aggregate ratio also, they are using another packing density theories. Okay, without the packing density, my student doesn't start their work. Okay, without simply, for example, 20 mm, 60%, 10 mm, 40%, not like that. Anything they are following some principles, the methods. But earlier, okay, like that only, 20 mm down, 60%, or 10 mm down, 40%, can mix it and prepare the compound. Not like that. Okay. There are so many methods or theorems also there. They are following the theorems like wet packing density and JDD theorem. There are so many theorems for coarse aggregate, fine aggregate combinations. Here, different specific surface areas. Someone is very fine, someone is average, moderately fine, like that. Okay, we are taking all the four materials, and thing is, we are buffering is only 35%. Remaining 60% is cement only. And sands. In the earlier last presentation, what we done in the Portugal, 2 sands are used, but here 3 types of sands, similar to our Indian standards. Okay, zone 1, zone 2, zone 3 sand, like in there, grade 1, grade 2, grade 3. Here also 3 sizes are used: 0 by 1, 1 by 2, and 2 by 4. And this is the superplacage with the polycarboxylate ether type. Superplacage are used here. And 2 fibers, one is polypropylene, another is basalt. And what are the aim of this thing is, first check the hydration of each material, hydration of cement, hydration of combination of cement and other materials. First check what is the heat flow, what is the hydration. Based on the hydration only can choose the best path, and find that compressive strength and flexural strength and dynamic modulus of velocity dm. Okay, that is for without the fiber. Then add the fibers, again check that things and find the results. Okay, here 2 kinds of fibers with the basalt and polypropylene with the modulus of velocity. That means modulus of velocity of the fiber, not the concrete, not the mortar. Tensile strength of the fiber, diameter of the fiber, length. That means aspect ratio of the fibers. Okay, tap water or potable water used for mixing of the mortars. Here, some of the apparatus or equipments are required to find the chemical composition of the given materials. Okay, you know that what?
Staple fibers and polypropylene fibers are reactable fibers.
Reactable.
Yes, those are reactive.
React with
Concrete.
cement.
That's not like
Basalt में, but polypropylene में. Basalt is very different actually. This is rock based fibers. It also not react with. I didn't observe it. But mixing of basalt is very different. Cannot simply add that. Okay. what I done in the mistake in my stay at Slovak, okay, prepare the samples and as usually prepare the samples and keep the samples in the laboratory and went. Next day came and discussed with the professor. Professor asked him, where are your samples? Samples are in the laboratory. He came along with me and observed that. No, these samples are not at all covered with any cover, wet cover. These samples are not at all useful for further testing. Throw away. That samples are not useful. But what we use in our laboratories, simply catch the specimen and dump. After 24 hours or 48 hours also they are keep like that. Basalt fiber also first we try to add that basalt fiber in the mortar, but not possible. Distribution of the fibers is not so correct. Some lumps or something, all the fibers are very close some location. That's why we thought that we can again use that mixer. That means what we call mixing. Okay, the mixer we are rotating and it will become some sponge type material. It becomes sponge type material. Then we are adding to the mortar. Yeah, this is the equipment we are using for finding of chemical analysis. Okay, what is the amount of calcium oxide? What is the amount of silica, SiO2, Al2O, Al2O, all these things we are using, and this is. You see the chemical composition of all four materials. You can see the silicon dioxide, SiO2 is more in silica film, almost 97. Majority of the composition is silica only in the silica film. And if you can see that silica film next to is 53.7 in metacolor and GG base is 37 and 19.1. Why I am focusing the silica? Why not other calcium oxide? Because if more silica is there, you can get the more secondary CSH, more pozzolanic reaction. It will consume more calcium hydroxide. Okay, calcium hydroxide creates the problems, durability problems. That's why we can consume the calcium hydroxide by adding the extra material. That material should have more silica, SiO2. If you observe that one, CGBS, next metacolor, next silica. And if you see the calcium oxide is more in cement and it is reducible. But calcium oxide is required more in case of geothermal concrete. That's why you can go for the GGBS. GGBS is right. Okay, these are the chemical composition. Okay. But my request is, if you start any work with the concrete, this chemical composition is very important. Okay, without the chemical composition, if you can start, you don't know what is the reason for the increase of strength, what is the reason for the decrease of strength. Okay, I observed many PhD vivas and MTech vivas. Okay, they add that material, but they don't know what the reason for it. Okay, don't do that. Okay, next is experimental procedure. The cement to sand ratio is 1:3 as per our code also we are following that 1:3 only. And there are two mixes 1:1 and 1:2. I am taking 4 combinations like this. Okay, what I told, 35% of the material is supplementary cementous compound. Yes, SCM 65 means 65 cement, remaining all 35 sugar. SCM 100 means 100% cement, there are no extra material. SCM 75 means 75% cement, 5% GD base, 5% metacolor, 15% silica. That means more silica film, what is the advantage? And less silica film, what is the advantage? And all the three are equal, that can what is the advantage? Okay, this is the study. Okay, this study includes the hydration, what hydration is going on, what is the heat of flow. Based on the heat of flow also we can check. Further, we can use the calorimeter. Calorimeter studies. These are mixed proportions. You can see that the cement 976.56. There is no extra materials, and the three types of sand, finite 1, 2, 3, and water bite ratio is constant. SP dosage we are for this SN100 0.5 percentage can achieve that properties satisfied the mini slump and bifunnel, but after adding these materials, but they are not satisfying that ethanol guidelines. Therefore, we are adding little bit amount of superglose. Okay. Just this is 75, this is 70 and 69. Remaining are change. Okay. Next 1:2. 1:2. This is 781.25 is the cement. These are the fine aggregate. Water bite ratio is constant. And SP also it is without the addition of the this material 0.6 in the water band ratio, and remaining are superplus is 0.8. Water band ratio is constant, and we are changing that these parameters, but ultimately the total is 781. Okay, after mixing this, the same specimens 4 cm by 4 cm by 16 centimeters. For compressed strength and flexural strength and dynamic models velocity dx at the age of 2, 7, 28. The last session we are conducted at the age of 7, 28, 91. But here 2, 7, 28. Why I choose the 2, 7, 28? Anybody? Okay. Initially, what is the effect of this addition of the material? And what is the effect of addition of material at 28? Any effect is there initially. That is the I want to check, because the pozzolanic reaction is very slow. If you add that any extra material, pozzolanic reaction is very slow. That's why I want to check what will happen at 2 days. Okay, testing procedure. This is yes, calorimeter is used for lead channel calorimeter is used for checking the hydration process and heat flow. And for phase change materials, we are using that TGA, that means thermogravimetric analysis. And this is DSC. This is the software, and this is the model. And okay, this is already discussed here. EV XRF is used for finding of chemical composition. Some microstructure studies also there, but I am not including this microstructure analysis. And SEMA is also there. And dynamic models of velocity was conducted at 2, 7, 28 days by using the ultrasonic pulse velocity test. Okay, each data we are conducting the 6 samples. Okay, test method. Anybody wants break? Okay, all heads are keeping like this. They are using the mobile phone, they are sleeping, I don't know. Any break you want? Okay. Here, ethanol guidelines we are following for test procedure as we discussed in the last session also. Ethanol is European Federation of National Trade Association. They are providing some guidelines. As of today, we don't have guidelines for self-compacting motors and countries, but some mixed procedure is there in the latest IS code. Mixed procedure 1026. Yeah, same mini slump and bifunnel we discussed in the one session also. Mini slump is used to measure the flow, flowability, and viscosity also. And bifunnel measures the viscosity of the water. The bifunnel test measures the flow rate and viscosity of the water. Same. I didn't change any apparatus, same apparatus, and dimensions also the same. I think at Slovakia that apparatus are not there. Okay, we fabricated the apparatus. We gave the instruction to the technician. Okay, these are the dimensions. This is the protocol. Okay, within 2-3 days, they made the slump core as well as frequent. At that time, they are not started. Actually, instead the institute they are totally cement chemistry people. Cement chemistry. Okay, they done the research on chemistry aspects on cement. Okay, then slowly they are starting that mortars and concrete. Now they are doing that heavyweight self-compacting concrete, lightweight self-compacting concrete. Heavyweight self-compacting concrete. They have that collaboration with Korea. They are this concrete used for shielding purposes for atomic laboratories. For shielding purpose, they are using heavy density concrete. The same dimensions. This is the 10, 20, 7, height is 6 centimeters. Same procedure. Pour the concrete, pour the mortar, lift it and measure the time. Once the mortar crosses the circle, measure the time, that is T20. And after the mortar crosses the circle, once the mortar flow stops, you can measure the dimension in 2 directions. That is should be 240 to 260. Okay. Then V-funnel, same procedure. V-funnel is the time required to empty. Once you can start that emptying of that V-funnel, and once it is completed emptying, the time lapse is nothing but a T. The flow of water is the lapse time in T seconds between the opening of the bottom outlet and the time when the light becomes visible from the bottom. Same thing. Okay. And tubes also similar. Sometimes I am using 4 cm, sometimes 40 cm. Both are same, don't confuse. And curing. Okay, I am worrying about this curing actually. I didn't take care that type of curing in India. I don't know what IITs, but in NIT, we are not following that type of care. Okay, the technicians, they are carrying the specimens as a just born babies. Immediately after the casting, they put that wet cloth. Immediately, without taking any much time, because they said that water may be evaporated. The water is not sufficient to hydration process. 24 hours, first 24 hours is very important. That's why they are taking very good care about this business. I will ask about it. Okay, this is the curing part. Read the sentence actually. After the completion of the casting, all the specimens are cured at ambient condition of 20 degrees C under 90% humidity for 24 hours. After 24 hours, the specimens were immersed in the water. Okay. At the same temperature, room temperature, the specimens are cured for 28 days. So after 2 days, you can keep the specimens out and conduct the test. Okay. Likewise, after 7 days, after 20 days. Okay. Okay, I will do a small break, 10 to 15 minutes. Okay, we will stop. Then next is only results. Okay, this is only the part. What is the planning? Next thing is results. Okay. Take small break and come.